Great. Thank you very much for that presentation. Just want to remind everyone, if you want to ask a live question, please raise your hand in Zoom. So maybe I can start us off. So Mahesh, from the paper, I believe if you include the observer layers, the Delos database has 12 log protocol layers, where each layer potentially has to perform local writes to manage their own state machine. How does that affect the performance of the system? Like how much duplicate work is being performed at the different layers?
Sure. So it does at first glance look like a lot of overhead. I think what saves us a little bit is this is all running within the same process. So from a software perspective, it's the same number of instructions. They're just happening in different places. You did hit on an interesting point, though, which is that semantically different layers might need to do very similar types of work. And we almost need a model for them to share information. For example, the view tracking engine is basically creating a membership layer above the log. There are other things that could use that membership layer. And right now, we just have them redundantly create their own membership layer. We don't have a model for engines to share state in a safe way. It's actually one of the things that happens once you create a modular system is you have 3 or 4 or 5 challenges now with modularity. So I'm hoping that either we will tackle this or somebody will.
Great, thank you. I believe we have a live question from Sanan.
Yeah, actually, I have a similar question like that has, is whether different engines can execute in parallel if they do not have dependencies.
Right. That's a fantastic question. So the current model is that there's a single thread that's applying every log entry one after the other. The reason we do that is if the system crashes, then the invariant is very simple. The state of the system is what you get after playing a prefix of the log. There are multiple types of parallelization we've considered. The one you mentioned, can we run multiple engines in parallel for a single entry? In most cases, you can, in principle. The only exception is, I think, the session ordering, where it's, you have to kind of order it a certain way because engines above it will not run based on what the session ordered engine does. The challenge we run into, though, is we want to give a fairly simple programming model to the people writing the engines. And part of that is we want to support things like throwing exceptions within that apply up call. And because of that, parallelizing within an entry, it's a little bit challenging. It's more complexity. And then there's a different kind of parallelization you can do, which is you execute multiple entries at the same time if they don't conflict. And again, there's some complexity there around what I think the database people call recoverability, which is if you crash and you come back up, you no longer have a prefix of the log. You have the prefix plus some Swiss cheese of committed and uncommitted entries. But there's a great question. I think in the constraints that we work under, because this is kind of like the chubby of chubby of Facebook. These constraints are that we bias towards simplicity at all costs. And we haven't really hit the performance issues with a single thread so far. But we will, and then I think what you described is pretty much what we're going to do.
Cool, thank you.
Great, I think we have another live question from Abhilash.
Yeah, thanks. Pretty cool work. So I'm curious, does it allow doing trade-offs between availability and consistency, or is there particular guarantee that Delos base layer provides and then everyone has to live with it? Or you can
live
with it?
That's an interesting question. So there's like two types of weaker consistency, right? There's a particular type of weak consistency where you have a total order in the system, but then when you do a read, you see a stale prefix of that total order. And the Delos architecture, because there's kind of a database over a log, it supports this type of weak consistency very naturally. If you do a read on the database and it doesn't synchronize with the log, you end up getting stale data. And you can actually reason about how stale it is. Do you get read your writes and things like that? there's a separate question that maybe you're asking, which is, does the log structured protocol layering have anything to do with weaker consistency? And I think it does, because ultimately you could insert a layer in the stack whose job it is, for example, to give you fine-tuned trade-offs as to how much of the log you're syncing with. We haven't done that, but I think it's possible.
Okay, thanks.
Let's take one more question. I think there's a question from Andrew Quinn on Slack. The question is, Delos targets Facebook's control plane databases. Is there a reason why, is there a reason why Delos would be inappropriate for Facebook's data plane databases?
Sure. So right off the bat, we don't currently have sharding. So a lot of our applications are, they have a lot of fate sharing you're running some scheduler within a data center, and you really want the fate of the scheduler and the data center to be tied together. So typically you're running one cluster within the data center. Most of the data plane systems tend to be geo-distributed, and they tend to shard for scale and so on. So you have one big unified namespace. So to some extent, I think that's one very big reason why. And the other thing, just as a final point, I think when you start building a system, you really bias towards what's important in the problem domain. And the design choices you make for the control plane are kind of different. You really want to bias very, very highly towards durability and consistency.
Okay, great. Thank you very much, Mahesh. I think in the interest of time, we should go to the next presenter. If you have any remaining questions, please continue them on Slack, and I'm sure Mahesh will go in there and answer them for you. Okay, so our next presenter is Sangming Lee. He is a software engineer at Facebook working on systems and infrastructure. He wanted me.
Great. I see that Mahesh is here. Hi. Yeah, thanks for the talk. This is really super interesting work. I will start asking some questions of my own. Yeah, other people should raise their hands in Zoom if they want to ask a question. Otherwise, go ahead and post the question on Slack, and I will read it, and we can have Mahesh answer it. So my first question about Delos is, when you showed the different engines, right, there was clearly an ordering to them. Is that important, or?
There's actually a funny thing there. The order on the slides is actually, it's different from the order in the paper. The order in the paper is the actual order that it's deployed in. And the slides, I kind of made it by memory based on what I thought it should be. In most cases, it doesn't seem to matter. There's some advantage of layering one thing above the other in terms of piggybacking. Layers can piggyback on messages emitted by higher layers. But that's about it. There are a couple of cases where it does matter, like that session ordering has to be very high because it's enforcing an end-to-end guarantee that things are arriving in a certain order. And interestingly, that one in production, we actually have batching above session ordering, and I was trying to figure out why today. But you're right. I think one of the interesting things is if you allow people to create these layerings and it's easy to change the layering, then they will actually mess around with the layering, and it's almost it's a double-edged sword. And I don't think we really addressed it, in this paper, or I don't think we even have a very good grip on it right now. So it feels like the kind of thing that it'd be very nice follow-up work.
Yeah, I was going to say that seems like interesting future work. Could you give an example of like a lower layer piggybacking on a higher layer?
Oh, sure. So we have these two layers. One is the view tracking, and the view tracking is basically doing membership above the log. It's keeping track of nodes that are playing the log. And so every now and then the view tracking layer will emit an entry just for heartbeating. It'll say, hey, I'm still alive. Don't kick me out of this membership. Now, if you layer something below that, like the log backup engine, which needs to do its own coordination for figuring out what to back up, then often what we can do is every time you emit a heartbeat, the layer below can say, oh, you're sending a message anyway. That's a durable append on the log. So I'm just going to attach whatever I needed to talk about to it. This is very similar to how network protocols do piggybacking. And again, we don't have a very good grip on whether any of this really matters. In this case, because does it really matter which one gets to piggyback on the other one?
Well, it's interesting, right? Because that seems to indicate that entries to the log have multiple potential events that trigger them, right? Not just client events, but also timers.
Internal activity, heart beating. That's true. Actually, there's a lot of chatter going on in the log. One of the insights is that the log is almost it's a type of network, right? It's just happens to be a durable, totally ordered network. I know this is something that should resonate with you too, because you've written a bunch of papers about things that are very similar.
I think if Ken Berman was here, he would say it's like virtual synchrony.
And it is, to be fair, I think if you think about those two pieces of work, this is a lot like Horus, which is there was a virtual synchrony follow-up system around in the mid-90s, Horus Ensemble, and they were doing very similar things for group communication. And I think what we're doing here is just changing the abstraction, but the ideas are fairly similar.
So let's take a question from Inho. He's had his hand raised.
Yeah, hello, I'm Ino from NUS. Thanks for the great work, Mahesh. My question is, I think it could be a general question because your work is claimed to be a specifically control plane database structure. So I'm wondering, in your experience, what would be the main difference when you try to design some structure for the control plane and data plane, and if it could be your design could be like extended for the data plane architecture.
There's actually, so there's an interesting question. There's one view that says, so the missing thing is basically the sharding and the scale out. If you're in the data plane, you need to scale out. And historically, it used to be that transactions and sharding and transactions and replication used to be entirely separate things, and you'd layer one on top of the other, in which case it shouldn't really matter. You can take these techniques and just apply them. But there's a lot of recent work. Irene actually has done things like Tapper, where people collapse those things for better performance. So one of the things that I've actually not figured out is how do you build a scale out system that still has this kind of nice, abstraction in the single shard case, and while still giving you some of the performance benefits of having one combined protocol. So this is, I think, probably where the frontier is with the shared log kind of systems. The shared log is a good abstraction for replication and consensus, but we haven't yet figured out how to build distributed transactional systems that somehow include the log as a building block.
I see. Thank you.
I guess I'll ask one more question of my own, which is kind of relevant to the question to your last answer. Have you thought about providing logs with different guarantees? So Taper in particular takes advantage of a log without ordering, but with replication fault tolerance, or a log that has ordering but not fault tolerance.
This is really interesting, right? So one of the, it used to be that when we built these systems, Corfu and Tango and systems like that, we thought the log had to be linearizable. And then at some point there was, I realized that wasn't true, because ultimately the way state machine replication works, you append an entry and then you wait until it shows up anyway. So it's okay if the log is stale. I did mess around with protocols where it's not a log, it's a DAG. But then things got complex really quickly. I mean, life above the DAG is still easy, but building a DAG is actually somewhat complex. And you get all these weird, and about this, you get all these weird ordering, cycles, and it's actually fairly hard to do a multi-shard consistent operation. So some of the simplicity goes away. I was kind of hoping that if there's an API and you have this kind of virtual consensus ability, that people would try out new types of logs. But to be honest, that hasn't really happened. I mean, we have a log, it works, and then people have just left it alone. So the bottom of this hourglass has not really seen that much expansion. Most of the work has happened at the top of the hourglass where people are building new applications. But I think this is also because of, my sense is if there were an academic prototype that did this sort of thing, then people would try out consensus variants, they would try out different semantics for the log, and it would get fairly interesting, I think.
Yeah, I agree. But there's something to be said for simplicity.
Right. I think
when you want things to work. Great. Yeah, thanks a lot, Mahesh. That was great.
Yeah.
So if you stick around, we may have time at the end for a panel.
Yeah.
But I will move on to the next talk.
That's good. Thank you.
Yep. All right, so let me again encourage people to drop questions in Slack as this talk happens. So our next talk is